Welcome to Understand the Math. In this video, we're going to analyze the graph of this function f of x that's shown here. We're going to find where it's increasing and decreasing, has local max or mins, where its rate of change is increasing or decreasing, and where it has inflection points. Let's get started. We're first going to identify where the function is increasing and where it's decreasing. A function is increasing when it moves upward as we move from left to right on the graph. This function is increasing in this part, and in this part. Since the letters in the graph correspond to the x value of the function, we can notate the intervals where the function is increasing as a to b, from d to e, and then from g to h. A function is decreasing when it moves downward as we move from left to right on the graph. This function is decreasing in this region and in this region. The intervals where the function is decreasing are from b to d and then from e to g. Let's now talk about local maxima and local minima. A local maximum is a point where the function reaches a peak and occurs where the function changes from increasing to decreasing. On our graph, that's where we change from green to pink. The function in this graph then has a local maximum at point B and point E. Let's go ahead and write that down. It has a maximum at point B and E. A local minimum is a point where the function reaches a low point and occurs where the function changes from decreasing to increasing. In our graph, this happens at point D and at point G. We'll write that down. We're going to write down D and then G. Now we're going to talk about rates of change and concavity. The rate of change of a function is increasing when the slope of the tangent lines to the curve increase. This occurs when the curve is concave up or opening upward like a smile. The rate of change of this function is increasing in this part and in this part. That's where the curve is concave up like a smile. Let's go ahead and let's write down those regions. The rate of change is going to be increasing in the interval from C to E, and then in the interval from F to H. The rate of change of a function is decreasing when the slope of the tangent lines to the curve decrease. This occurs when the curve is concave down or opening downward like a frown. The rate of change of the function is decreasing in this part of the graph and in this part of the graph. The intervals where it's decreasing are from A to C and then from E to F. Lastly, let's talk about inflection points. An inflection point is a point on a graph where the concavity changes from concave up to concave down or vice versa. The function in this graph has an inflection point at point C, where it changes from concave down to concave up, at point E, where it changes from concave up to concave down, and then at point F, where it changes from concave down to concave up. Let's go ahead and let's write down those points. We have inflection points at C, E, and F. So, to recap, we've covered increasing and decreasing intervals, local maxima and minima, concavity, and inflection points. These are fundamental concepts for understanding the behavior of functions from their graphs. I hope this video helped you better understand how to analyze the graph of a function.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.